Hello again. Welcome. I'm Mr. Hicks, and we're going to be talking about some stoichiometry today. This is the third part of my stoichiometry series, and the first part we learned how to use this thing called a molar ratio to make the switch from one substance to another substance in a balanced chemical equation. Another one where we learned how we can take this molar ratio and add things onto it, like as if we were going to change it from grams and then figure out how many moles of some other substance I need. Finally, today, we're going to work on the mass-to-mass problems. And you're going to see how the molar ratio fits right into the center of this type of a problem. When we get done today, I hope that you're going to be able to follow the process of stoichiometry. There is a process here. In fact, I'm going to give you a little poem to kind of remember, and a little saying for you, a little mantra, and that'll help you follow this process of stoichiometry. You'll see that it's a pattern, and if you follow it the same way every time, you're going to get it right. Next, I would expect you to be able to handle these mass-to-mass problems. And finally, I want you to be able to calculate stoichiometry problems with other units in it as well, like liters or particles, atoms, molecules, all those good things. All right. So these stoichiometry problems can get kind of messy, get kind of big. So I thought maybe I would give you a glimpse of what the process is. So I call this my stoichiometry roadmap. As you can see over here, I have some starting points in the process. We may start with grams. That's going to be the first thing we start with because we want to be able to do mass-to-mass problems. We could also start with things like liters or particles like atoms and ions. The first step is always to take these and change them to moles. After that, we'll use the molar ratio to make the switch from one substance to another substance. That'll leave you with moles of that other substance, and then from there we can change it into grams or liters or particles of some type. Notice that the molar ratio is right there in the middle. Every time we're going to have to go through that molar ratio. You could start from any place over here, and you can end up at any place over here. How many steps you have to do depends on where you start and where you finish. So, here's the plan, and this is the process of stoichiometry. First, we need to change this to moles, whatever it is. Use that molar ratio, and then change it to whatever the problem is calling for. Let's try one. Okay, I've put our saying up here on the top, change it to moles, molar ratio, change it to whatever the problem wants, and in this case, it wants grams. Check this out. I'm taking some zinc and reacting it with hydrochloric acid, and I'll produce some products over here. The question is, if I had 6.54 grams of zinc, how many grams of hydrochloric acid will it require? So, to do this problem, we're going to start out with our question mark format. Now, some chemistry teachers will teach you how to string this together, all three of these parts. And with dimensional analysis, we'll have all three of them strung together. I'm going to break it up into the three parts itself to start out with. But on the very last problem, I'll show you how you can string it together and maybe make these a little bit shorter. If that makes sense to you and you like it, go for it. If you want to break it up into 3 steps, that'll work just as fine too. Okay, so let's start this out. We'll start with our question mark format. It says, how many grams of hydrochloric acid will we need if we're going to consume this 6.54, 6.54 6.54 grams of zinc. So the first step up here is to change it to moles. So I'm going to take the zinc and I'm going to change it from 6.54 grams of zinc to how many moles of zinc. Looking up the molar mass from the periodic table, I pulled a good one here because it's 65.4 grams is the molar mass from off of the periodic table, and that's equal to 1 mole of zinc. So crunching this in my calculator, I made it easy on myself. It's just 0.10 moles of zinc. Step 2. Now that I have how many moles of zinc, I'm going to use the molar ratio to make the switch between zinc and hydrochloric acid. So, starting with my 0.1 moles of zinc, I am going to set up my molar ratio. On the bottom, I'm going to put moles of zinc so it will cancel. And on the top, I'm going to put moles of the hydrochloric acid. Again, the molar ratio is always moles over moles, making the switch between two different substances, and these numbers here come from the balanced equation. So up here, if we see for zinc, my coefficient for zinc is a 1, and my coefficient for hydrochloric acid is a 2. Let's put those in. I'll run this through my calculator, and I get 0.2 moles of hydrochloric acid. All right, we're down to our third step. I told you these were long. We're going to change it back to whatever the problem wants, and in this case, the problem wants grams. We call this a mass-to-mass problem because we're going from grams to grams. So to finish it off, we're going to take our 0.2 moles of hydrochloric acid, and we're going to change that to grams of hydrochloric acid. So on the bottom, I'm going to put 1 mole of hydrochloric acid. Again, watch out for this right here because people want to use this 2 from up here, but we don't want that. That we use in the balanced, or excuse me, in the molar ratio, but here we want to use 1 mole of hydrochloric acid because 1 mole of hydrochloric acid makes it so that we can convert this to this 36.5 grams. I got this from the periodic table. Okay, crunch that out, and the answer here is 7.30 grams of hydrochloric acid. Woo! I told you that was long. Kind of needed that roadmap, didn't you? Let's just review our steps here. The first step was that we needed to change it to moles. I was starting in grams, and I can't use the molar ratio with grams. I have to be in moles. So I had to change the grams of zinc to moles of zinc. After that, I could use the molar ratio, setting it up, making the switch to hydrochloric acid, and then once I know how many moles of hydrochloric acid, I could use the molar conversion here to change this over to grams of hydrochloric acid. Well, that was a lot of work. You think you're ready for this much work? I don't know. Let's give it a good try anyways, huh? Here's my next problem. It's going to be the oxidation of aluminum to form aluminum oxide. And there's our problem. Why don't you give this a go and do the 3 steps. And when you're done, just hit the play button again, and I'll be right there waiting to show you how I would do it. All right, welcome back. Hope that didn't take too long. So what I'm going to do here is set this up with my question mark format. So down here, I'll start out with my question mark. It says, how many grams of oxygen gas will it take to oxidize this 2.7 grams of aluminum? There we go. First step, let's change it to moles. So on the bottom down here is going to be grams of aluminum. And how many grams? Oh, I was tricky again, saving myself some work. 27 grams of aluminum, and that's equal to 1 mole. Again, this is a 1 mole because I'm changing it to grams. Don't be using this until we get to our molar ratio. Also, this is changing it to grams to moles of aluminum. Don't goof around and put that oxygen in there already. We can only make it aluminum and oxygen in the same set of fractions here when we're using the molar ratio, right? Okay, those are some common mistakes that I've seen in the past. All right, now I'm going to run this through my calculator, and oh, look at this. It's 0.1 moles again. Trying to make my life easy. Okay, I'm making your life easy too, so no complaints. Here we go. Now that I have my 0.1 moles of aluminum, now I can use that molar ratio and make the switch. On the bottom, I'm going to put moles of aluminum, and on the top, I'm going to put moles of oxygen. Again, it's moles over moles, making the change to a different substance, and now I'm going to grab these numbers from my balanced equation. Again, don't know where these numbers came from? Right there they are. So now that I've set up that molar ratio, I run that through my calculator, and I get 0.075 moles of oxygen. One last step. Now I'm going to change it to grams. I've got my 0.075 moles of oxygen. Now all I need to do is change that to grams. So on the bottom, I'm going to put 1 mole of oxygen. And on the top, I'm going to put 32 grams of oxygen. I got that from the periodic table. And when I run this through my calculator, I end up getting 2.4 grams of oxygen. Okay, hey, I'm hoping that you're seeing a pattern here. The pattern goes that we're going to change it to moles, right? And notice right here, the 1 mole is on the top. That's always going to be there, 1 mole on the top in that first step. And then the molar mass from the periodic table is going to go down there. Check your notes. It was the same way last time. Next is our molar ratio. We should be getting pretty good at that now. And then finally, we're going to change it back to grams, and check this out. There's 1 mole on the bottom and the molar mass on the top. Again, check that last problem. It was the same way there. So there's a pattern that you're going to see over and over and over again. You're going to change it to moles, 1 mole over its molar mass, molar ratio, what we want to get rid of on the bottom, what we want on the top, and then change it back to grams, 1 mole on the bottom, molar mass on the top. Booyah! We're getting there. Okay. So how about you try this one more time and hit the pause button, work this one out, and then when we come back, I'll show you what I did. Okay, how'd you do? Here, while you were working, I went ahead and scribbled in what I had for this one. And so let's just go through this quickly, and I'll show you what I did. So first things first, I changed it to moles. I set up my question mark format, and I had 65 grams of mercury oxide, and I changed that into moles, and that came out to 0.3 moles of mercury oxide. After I changed it to moles, I could use my molar ratio. Now notice this one, molar ratio, the numbers are the same on the top and bottom. That's because from the balanced equation, I had 2 moles of mercury oxide and 2 moles of mercury. Just because they're the same and they're going to cancel out doesn't mean you should leave it out of this process. I know that's a tendency that we might want to do, but don't do that, because this is the part right here where we're going to make the switch between the mercury and the mercury oxide. So just to keep everything, in order, making sure you don't get lost in this process. Don't skip things. When you see them a 1-to-1 ratio or something like that, don't do that. Write out these substances so that you can get things in their right places and don't get lost in the process. So then finally, I took my 0.3 moles of mercury, I multiplied it by the molar mass of mercury, and I found out that it was 60 grams of mercury. All right, I'm hoping you did great. I promised you that the last one I do here is going to be one where we'll use some things that are different. So this time, I've set one up with iron and water. As it oxidizes, makes rust, and releases a little hydrogen gas at the same time. And look at here, oh, this isn't a mass-to-mass problem. I'm going to be switching from atoms to liters. How's that? So I put our proportion up here that we use as we move from moles to molecules to grams to liters. So the other thing I'm going to do that's different with this one is I'm going to string this one out. So I'm going to do like up here where I'm going to change it to moles, and then right away I'm just going to set up my molar ratio, and then right away after that I'm going to change it back to liters. So watch how I do this. If you like this way, use it. If you don't. You'll get the same answer either way. All right, so here I go. I'm starting this problem out with 1.25 times 10 to the 23rd atoms of iron. So my first step, I'm going to change it to moles. So on the bottom, I need to get rid of atoms down here. So we know what that number is. Yep, Avogadro to the rescue. 6 times 10 to the 23rd. Ooh, that was messy. Let me clean that up. I guess I needed a little more space. (6.02 times 10 to the 23rd atoms. There we go. And on the top, I'll make this 1 mole of iron. Now, instead of calculating this out on my calculator, I'm just going to go ahead and put in another multiplication sign and do my molar ratio. On the bottom, moles of iron. On the top, moles of hydrogen. Because that's what I'm changing it to, hydrogen gas. Grab my numbers in the balanced equation here. And then watch this. Last step, right there. On the bottom, I'll put moles, so that'll cancel. And on the top, I'm going to put liters. How many moles? 1 mole, because we're changing it to liters, right? And how many liters? 22.4. Add STP. Some people worry about that, and they're like, what's STP? Stands for standard temperature and pressure. You know, gases, they take up a lot of space. And if you change their pressure or their temperature very much, then they'll change how much space they take up. They expand or contract depending on their temperature and their pressure. So because of that, we have to have a standard or a set amount, a set temperature and pressure that we work with. And that happens to be 0 degrees C and 1 atmosphere, we say, of pressure. So at this point, that's about gases. That might be a little later in the year. Maybe you've already covered it. I don't know. But at this point, we're just going to take that as comfort food. And when we see STP there, we're just going to ignore it and say, okay, everything's normal. I don't have to worry about anything. I can use 22.4 liters. So if you were worried about that, that's what that is. All right, set this one up in your calculator just the way it looks. And you're going to be dividing by things on the bottom, multiplying by things on the top. And in the end, when you crunch all that out, you're going to end up with 6.20 liters of hydrogen. Well, there you go. This is the big daddy of them all right here. And we're switching things, 3 different conversion processes that we have to go through. So stick to the process, change it to moles, molar ratio, change it to what the problem is calling for, and you're going to do fine. Well, that's all for now. Have a good time and have some fun with your chemistry.